Welcome back to Ox Tools. I'm Tom. So for all those loyal oxen out there that love a batch of meatloaf, guess what? It's Meatloaf Monday. Let's check it out. We got a little teaser video. So we're gonna have Mark II with the improvements here of the helical milling setup here. If you guys remember, so I've got a servo motor encoder down here, and I'll show you the control box. There's going to be a separate video for this. So here's the control box. I can do individual indexes. I can change the ratio. I can change the move angle, and I can change the indexer ratio. In this case, it's 40:1 right now, so I have control over all of those things. There's a little bit of math involved just because of the simplicity of this control and to take advantage of the 8,000 count per rev encoder that's on the setup. But we're going to do a whole video on this, so stay tuned. All right, this next one is a little plug for my buddy Gary Brown, and he has a YouTube channel called Old Iron Machine Works. And if you guys haven't checked him out, you should go check him out. Gary's a cool cat, super nice. This guy has a knack for scrounging up machinery and finding screaming deals on equipment. I've been out to his place, the pre-COVID, right, and seen his shop, and we hung out a little bit. And he's in Rio Vista, actually, which is not too far from here. It's right on the river, and that's the bridge there at Rio Vista in this picture. Anyway, Gary, he is tireless. That guy will tear into a machine and take it apart and repair it, and he's doing some deep dives into some machinery repair. So anyway, go check him out and see if you like what he's doing. And if you like what he's doing, throw him a subscription, and you get a little ping when he puts a video up. He's got this kind of monotone speech pattern. So, but he's just the nicest guy that you can imagine. You know, this is the guy that you know, he'd take a bullet for you, right? If you're a good friend, right? He's that kind of a guy. So anyway, go check him out. Old Iron Machine Works on YouTube. All right, this beast comes to us from all the way from Australia, believe it or not. And I don't want to know what that costs to ship. But what we have here, this is from Joe Hovel, Hovel, and he's a fan of the channel. And I guess his buddy makes these collet blocks, okay? And it's kind of interesting because it's got, what is this, 12 sides or whatever, 12 divisions? Yeah, 12 sides. And it's made from probably a square or a hex block, and then more flats are added to it. But it uses these big whopping ER32 collets, right? This one's kind of interesting, because you can hold up to an inch, maybe even a little bit more. I haven't looked at the range of ER32 collets. He sent this to me a while ago, but I had to order some collets, and I'll tell you, they don't give these things away. And that's one of the problems with the ER system. When you get into the big collets, they're kind of expensive, right? So. One, I don't know why you would need unless it's something like this, but an end mill holder or whatever, you'd never use an ER32 to hold a 1/4 inch collet or a 1/4 inch end mill. It doesn't make any sense. So, there's systems all the way from ER8 up to ER40, right, which is even bigger than this. So anyway, enough said about that. But so you can get 12 divisions out of this, and what's nice is you're always clamping on a flat, you're not clamping on a crest, right, which is kind of cool. So if you got some anything that's divisible into 12, right? You can kind of do that. So I don't think I have a wrench. I don't have a wrench. So I guess I don't know if he's selling these. Let's see. Let me look at this thing real quick here. Manufactured by a friend in his factory, available from M&G Productions. www.mag-pro.com.au. I'll put a link in the description if you want to go check it out. Although I got to believe that shipping from Australia is pretty gnarly. So you know, that's, I don't know, that's 3 pounds or something like that, 1.5 kilos or something. I don't know. But pretty cool. And Joe, thank you so much for sending these or sending this. And I'm going to try it out because I do use these occasionally. They're kind of neat. You know, this one you can use this way, or you can use it that way, or you can set it up at an angle, you know, on an angle block or whatever you want to do, right? So they're kind of for those quickie setups, and it'll hold up to an inch, you know, through the rear end of that. So pretty cool. So thank you. I'll just add this to my arsenal of collet blocks, and yeah, I know what's going to happen here, right? I'm gonna like, oh yeah, I'll use that collet block. That'll be great for this job, and I'll go, and I won't have the right collet. So I'll end up making some silly bushing or something that that goes in a collet, you know, so a collet in a block, right? So that's probably what will happen to me. So that's usually the way this kind of stuff goes. So anyway, Joe, thanks again for sending that. I appreciate it, and I apologize for how long it's taken me to show this on video, and that doesn't mean I don't appreciate the gesture. Thank you, sir. I appreciate it. So you guys know that I'm a big fan of Taft Pierce metrology equipment. Just their tools in general, I kind of like them. It's an old American company, Woonsocket, Rhode Island. They don't exist anymore in the same form. I think the way they exist now is Suburban Tool bought the rights to the name and is manufacturing some of the original designs in, you know, modern times. But they're not making anything like this, I can tell you that. So what's in here, huh? Everybody wants to know. And this is an eBay find. I've been kind of eyeballing one of these, well, I should say stalking one of these since I saw one in the Taft Pierce catalog. So that's how you figure out all the stuff that you need, is you get the stupid catalog and you go, oh, I got to have one of those, right? And then you start prowling around to see if you can find one. Well, what we got here is we have a little itty bitty sign bar, and it's just cute as heck, isn't it? Look at that. So it's 3-inch center to center. But what's really special about this is how they made it, and they made it like in a really difficult way. Okay, let's just put it that way. Back in the day, right? Now this is relatively straightforward now with wire EDM, right? So this was form ground. Okay, let's pop it out of here and we can take a look at that. Okay, and I mean, it's just, you know, it was expensive in the day, right? So they put it in a nice box, right? So these rolls, if you can call them that, you can see, you know, they've been lapped, but you can see the remnants of the form grinding. So what they did was they dressed a wheel with a radius on it, and they ground that. Then they moved over the exact right amount and ground it again. Now, so that's a pretty tough way to do that, right? And the normal sign bar, and you know, I don't have one handy, right? The way they do it is they have a shelf on opposite sides. So when you check them, if there's any discrepancy in the roll centers, the center to center on the rolls, you can adjust one if it's long, or you can adjust the other one if it's short, right? So you can change that relationship pretty easily, right? Fairly easily. So this is a little tougher, right? So I don't know how they were checking these, if they checked them on the machine, or they would take them off and check them and then regrind them, or my guess is, once you're set up to do these, you're going to do them like slices of salami. You're going to have a whole bunch of these, right? So you're going to do 10 at a time or something like that, I don't know, right? And, but that's about, well, here's another Taft Peirce Sine bar here, right? And once again, this is probably one of the harder ways to make one of these, right? Is you got to hit these centers like dead nuts, right? And this is a, oh yeah, this is a laboratory grade one here, right? Which means they got it even closer. I can look in the catalog and tell you what the accuracy of the roll diameters and their centers is, but this is laboratory grade or whatever. This particular sine bar, you see a lot of these on eBay. They're pretty common. In use, these are a little harder to use because this roll's not touching, so you got to stack some blocks under that to bear against that. So they're just not quite as handy. They were designed to mount to an angle plate like this, or clamp to an angle plate like this, and be kind of used like that. That's kind of what their intent was. But once again, it's just a beautiful piece, lap rolls, nice. But this is hard. This is even harder to do. But for those folks out there that have access to wire EDM, this is cream cheese here. Actually, I'm going to grab another one that's a wire EDM version, and I think I got one right here. Handy one, yeah, I do have a handy one. This was made by Mr. David Ramos, and this is the wire EDM one, okay? And it's nicely done, This one's actually pretty handy, right? Although it's not 3-inch. But you could easily make a 3-inch version of this, right? So those guys out there with wire EDMs, get busy. This is pretty cool here, though, I have to say. And I used it already, too. A friend of mine needed a tapered reamer of a weird taper. It was for I can't remember the taper now, but it was for a guitar tuner. And he had to ream the holes in the neck of the guitar for these new gear-driven tuners. And it had a 1 in 30 or 1 in 24. I can't remember. It was some weird pitch of taper, and it kind of an odd size, right? And the size range that he needed to ream. So you could buy one for $200 or whatever, but he asked me to help him out, so I helped him out. So anyway, Taft Peirce Sine bar in a purple velvet box. What's not to like about that? All right, so this one is a result of an ordering mistake some years ago by a gentleman named Lloyd Fisher, and I guess he sat on it for quite a few years and then started watching my videos and said, gee, Tom might like to have that. So he emailed me and I said, yeah, that sounds good. I'll have that. That's kind of nice. And what we have here is we've got a really nice CBN wheel, okay? And it's a Norton, so it's kind of a name brand. Now this one's unique in that the abrasive is on the face here, right? So it's mounted this way, so the abrasive is really, it's meant to grind stuff this way, right? Not on the periphery here. Now it's kind of a narrow band, but that's okay. And let's see, what grit is this here? 120 grit here, and it's a very nice wheel. So Lloyd, I'm sorry that you didn't return this in time, and it ended up here because this is a pretty nice wheel, and I can think of some uses for this particular orientation here. So Lloyd, he's let's see, where is he? He is in Colorado, Longmont, Colorado. And for anybody that's out that way, anyway, he has a little shop out there and he plays around in. And anyway, Lloyd, thank you so much for sending that in. And I'm going to try to put that to good use so you can see it on video again, okay? Actually, I should put his name in there somewhere, so when I mount it up, he'll see his name spinning around, right? All right. So this one here, this is funny. This comes from a loyal viewer. His name's Glenn Stasi, and he's in Laurel, Maryland, and he's been watching the show for a long time, and he reached out to me. He knows I'm into lapping, right? So he said, "Hey, listen, I got this lapping film, and I don't like the way it behaves. It's not working for what I want to do with it." I guess he's a woodworker, so he's sharpening plane blades or flattening the soles of planes or something like that with this. And this is a commercial product and tools for woodworking, and it's a abrasive film for scary sharpening is how they title it, okay? And what intrigued me was it's actually very fine grit. The white is 0.3 micron abrasive, which is that's pretty small. And the gray is, let's see, is this, yeah, this is 5 micron. Yeah, that feels pretty rough. And then the dark green is half micron, 0.5 micron. Now, what's interesting about this is it has an adhesive backing, which I think is one of the shortfalls with some of these diamond films, right? Is keeping them in place while you're using them, right? And you know, I generally do this kind of stuff I have one surface plate that I use for this kind of stuff, and I'm going to stick it down. Now you can put a little water underneath the diamond films or whatever, and they'll sit down pretty good and kind of suction down, but my experience is that they want to move around a little bit at the wrong moment. So anyway, Glenn sent this along, and I teased him a little bit, and I said, well, maybe it's an operator error why you're not getting the results you want. And he said, thanks a lot, right? You still want this or what, right? Anyway, we both got a laugh out of that, and he sent it along. So Glenn, thanks for sending that. I want to try it actually on something here. So we got these little strips. Let's try one of these little strips. Let's get something that's already pretty good, and we'll try a little piece of this and see what we can do with it. It's definitely got a good adhesive on it. It's going down nice. So in general, I don't recommend using abrasives on your good measuring surface plates. It's just not a good idea. This particular plate is my abuser plate, I would call it. I do use abrasives on this particular one, and understand that it's not as flat as it could be. So this is the 0.3 micron, which is pretty damn fine. I don't know if let me flat stone those first. Make sure there's no Dingus McGee's sticking up. So these are precision ground flat stones for those folks that are wondering, and you can see that it highlighted some of the high spots there. All right, let's give this a few strokes on here and see what happens. I see some brightening, but this is probably too fine for how for this particular block here. But we'll give it a go. See what happens. Oh yeah. Yeah, yeah, this needs to start out coarser, but it's certainly brightening that up. Like I said, 0.3 micron, that's pretty dang, that would be more like this here. Something that's already ground nice and yeah, I didn't see any change on that one, so. All right, anyway, yeah, you can see that it's taken off, there's some material on there. Now let's see how hard this is to get off here. Let me just try with the old rubbers here, okay. Oh, that's nice, it comes right off. And I don't feel any residue, which is great, but you can see that there was some metal transfer there. It was doing something, but much too fine for, you know, certainly that one. Yeah, even that one too, so. Okay. All right, well, thanks, Glenn. Appreciate that, and we'll try those out and see if we can make use of that. Thank you, sir. So this one, this is kind of an interesting deal here. And what this is these are distributor cams, old Volkswagen or Bosch distributor cams. So these particular lobes here actuate the mechanical points in the distributor. And then there's advanced weights that are that retard or advance the timing that spin on these little pivots here. So these are sent to me by a viewer that prefers to remain anonymous, and you know, he was asking me some questions about how you might build these surfaces up, right? Or repair these cams, because when they're worn, and you can see the wear on this, right? It's got a little, you know, dirt gets in between the little phenolic follower and this, and just abrades this after thousands of miles, right? And he also wanted to check the hardness of these. And honestly, I was pretty surprised to find that this one is not very hard at all. This is just basically machine steel here, and a file cuts this really easily. Now this one, I think, is older, this is considerably harder. And you can see that it's not as worn, right? And it probably has even more miles on it. So, you know, maybe they changed the process a little bit to make it cheaper, and this, you know, was enough life out of the unit that it didn't make any sense to, you know, that's how a lot of these manufacturing decisions are made, right? So this lasts 200,000 miles, and then the rest of the car's falling apart, but at the time you could probably buy another one of these, so no big deal, right? So why make it supercalifragilistic, right? And, you know, just to spend more money, right? So anyway, he asked me, you know, we talked back and forth on email a little bit, and so I started, he kind of caught my interest, okay? This is a dangerous thing, right? And, you know, we started talking about measuring these cams, right? I said, well, gee, with modern CNC equipment, right, you know, cutting this profile is like, you know, a simple matter, right? You could do this in the mill pretty easily, right? I said, why don't you just, you know, save the guts of these things and just make a new shaft, or he sent me some pictures, make a new shaft, right, out of, you know, something, and, you know, have a run of 50 of these made or whatever by a CNC lathe guy, right? And gee, if you have live tooling, they can probably cut this profile at the same time, right? And you make it out of something like, you know, 17.4 H900 or something like that, right? And it's, you know, it's 40 Rockwell or something like that, and it's going to go another 200,000 miles, and it's not going to rust, right? So, you know, that might be how I would approach something like this. But anyway, like I said, he kind of caught my interest, right, in that this is an interesting measuring problem, right? And so he sent these along, and I started looking at them, and I'm like, oh, wow, this is like a real cam here, right? There's you know, it's not flat and just into a normal radius, right? There's some business going on here, right? Although how much it matters is probably arguable, because basically all it's doing is separating the points at kind of the right time, right? And when you set the timing, right, that's what you're doing, is you're basically setting that point. But this became an interesting measuring problem, and that's what I'm sharing with you guys, right? So how do you measure that, right? How the heck do you measure that? So let's talk about that a little bit more, and then I'll show you what I did to kind of get this profile and get some measurements on that. All right, so probably the right way to do this, okay, if it's truly a cam, right? In fact, I've already separated this, so I'm just gonna take it off here. So we're gonna set it on there. This is just for illustration purposes. So what we can do is, we can generate a curve for this by rotating this by a prescribed amount, right? And noting the nominal lift, right? So you can plot this over, lift over degree, right? So, you rotate this 1 degree, 1 degree, 1 degree, right? And you have an indicator here, and you're measuring the rise or the drop, right? And so basically you generate a a curve like this, and then this is your degree increments, right? So now if we want to convert that into something digital that we can actually use, right? So what you end up with is something like this, right? So here's your center of rotation, right? And this is how I've done it in the past, right? And is basically you're going to end up with some points out here, right? And I'm just going to draw some kind of random points, right? Okay, and let's just go all the way around. And this is a crappy cam, right? All right, and then what you do basically is between those points, you draw lines between those points, right? And if these are closely spaced, right, you can convert that line into kind of a spline, right? Which actually does some mathematical smoothing to it, right? Now, if your points are close enough together, well, they're not there, but okay, you kind of get the idea, right? So there's a radius to each one of these, right? Okay, and then there's an angle to each one of these, right? There's an angle between each one of those. So now you can plot that based on the center of rotation, right? So now we can convert that into electronic information that we can cut that profile, right? And now you see, if you look here, if we look at this degree wheel here that I have, right? So these are 1 degree increments here, right? And you can see how close together they are, right? So imagine if they're in here, right? So a 1 degree spacing is going to be more than adequate to map that curvature, right? So that's a lot of work, though, and more work than I was willing to do, because I'm like super lazy. You guys know that too, right? So what I did is I said, hey, listen, dude, is it okay if I pop this loose from this, from the little, the weight plate, and then I can put it on the optical comparator, right? And I can look at those curvatures, right? And that's exactly what I did. And let's go, I'll put it on the comparator and I'll get it lined up again, and you can look at that and kind of see what that cam looks like. And it has multiple radii, so there's at least 3 radii in this thing that I can see on the optical comparator, right? So let me go set that up, and then I'll get the camera over there and we'll take a peek at it. Okay, so here, this is that Volkswagen Distributor Cam, and the lobes are all the same, going in one direction, right? So this is a good example right here. So you can see that there's a very large radius here, right? You know, this is a kind of the flattest section of the cam, and then it goes into a radius, okay, that's distinctly different than this one. And you know, it looks like it starts right in this region here, then that goes along for a little ways, and then it gets even tighter, okay, so which I'm going to say is somewhere in this region right here, right, where it starts and it goes like this, right. And so I've identified 3 different radii here, right, and I used an overlay chart here, and I matched up the curvatures to the overlay to measure those radii. And this is at 20 times magnification here. So that's how I did it. And then I started doing an electronic drawing of and trying to blend those. So you got some tangency issues, right? And then you also have you know. Anyway, it's not as straightforward as you might imagine to construct that curve, right? At least I'm finding it to be. So it's an interesting thought exercise. Okay, is anything going to come of this? I don't know. I'm having fun playing with it and using my metrology tools to kind of measure it and horse around with it a little bit. And hey, this guy will get some electronic data that maybe he can use to manufacture some new shafts for the deal. So anyway, that's kind of where it's headed. Interesting measuring problem, and it's not done yet. It's just something I'm fooling around with kind of in the background that's of interest to the metalworking community. So that's why I'm sharing it. So kind of neat, huh? So a lot of you guys know from watching my channel that I collect these machine badges, right? The different badges off machines that have been scrapped out or are no longer with us. Anyway, I think I found a expandable modular way of displaying these, I think. So I was at the art store with my wife, and I saw these. And these are birch panels, and you know, they got a little bit of thickness to them. It's just thin plywood on a little frame here, like that, and they're pretty cheap. I think these are $12 or 12 or 15 bucks, something like that, right? And you know, it's not something that I want to build, right? And because you know, these things keep showing up here. And so I need kind of a modular way of displaying these and kind of expanding on it, right? And you know, you can't have one gigantic one, right? So having multiple smaller ones is probably the right solution, right? So this is, now these aren't attached yet, okay? This is just kind of a trial layout, right? So I painted them with this kind of you know, kind of a neutral background color, right, to make the labels pop a little bit. And so I'll tell you what the next problem is arranging these, right? You're like, oh wow, well, that one could go there. And you know, should I put all the ones that are from England on one by themselves, or all the ones that are elliptical on one, or should I mix elliptical and rectangular? And I swear to God, this is as far as I got. And it's pretty awful, actually. And so I think what I'm going to do is I'm going to randomize the process somehow. I think I'll put all these in a box or something like that, and I'm just going to reach in the box and keep pulling them out until I fill a board. And whatever order they come out is how they're going to go on the board. And because here I went with all rectangular, right? And it doesn't look quite right to me either, right? And so somehow I got to randomize this. But anyway, this is moving forward, and thanks to the viewers out there that keep sending me, like Bruce, and let's see, who sent this one? I forgot who sent this one. This one weighs a ton. It's cast iron here. Joe Way sent that one, right? And my friend Andy Buchanan sent those. And let's see, Graham Petty. So anyway, guys keep sending me these things, and I'm trying to honor them by displaying them in the shop because they do look cool. And look at that one? Rolls Royce, right? So that one's got a mounting problem. I'll probably have to drill holes for that one. So, because I don't want to chop the studs off of that, right? So, anyway, so look, I got all kinds of problems here. So, so anyway, this is moving forward, and I'll probably, what I'm going to do is I'm going to use some, just some dots of silicone on the backside to stick these down, so that ultimately that you could pull them off if you wanted to pull them off and clean them up, and it's not going to harm them permanently. I don't want to screw them down because that's just a lot of work, and so that's how my framing buddy did that first one, is he used some silicone adhesive and just plopped it down, and it looks wonderful. So anyway, I just wanted to show this, and yes, it's moving forward. All kinds of things are moving forward here, and I'm just sharing this with you because I'm excited about it, and it's pretty cool. And I appreciate you guys sending all the tags in. It's awesome. So.